Hello class. Sorry I couldn't be there with you today, but you're going to be my guinea pigs for my very first video. Okay, so I didn't want you to miss this. The next and last concept that we have in regards to the equations are equations with variables on both sides. Okay, so that just means that we're going to have to be moving around the variable and the constants on both sides. So if we were to look at an example of something that we did in class, remember how we balanced things out, and this looks very familiar to you, a two-step equation. We would have had 8x plus 17, and then it would equal 35. And we would know that we would need to go ahead and get these balanced by taking 17 away here and taking it away here, and then dividing both sides by 8 to find x. There's not much more that you have to do except for there's one step ahead. What if we went ahead and we added something like this? Well, now you have two x's, you got the variable on both sides, and then you have a constant on both sides. So you still need to be able to isolate the variable, meaning getting the variable all by itself. So you have a couple of choices. Remember when we did pawns, let's just say we have 8 x's here, okay? 4, 5, 6, 7, 8. We have 8 x's. So now we have 2 over here. And you don't want to see me draw out 35 ticks and 17. I think you get that. But remember, we want to go ahead and we always take care of the addition and the subtraction first. Okay? You always do that first. Then you multiply or divide second. All right, so let's look at this. We'll go ahead and save these, but if you can remember from that hands-on algebra app, we were already dealing with pawns on both sides. So you can just see this as 8 pawns and 2 pawns. Okay, so we need to go ahead and if we take 17 out here, we have to take 17 out there, right? When we take 17 away from here, it goes away, right? But if we take 17 away from here, right, we go ahead and we get 18. All right. Now here we would cancel out 2 of the x's, right? That's like taking away the 2x and bringing it over here, which if you take away 2 of these, you've got a 6x left. So now you have 6x equals 18, and we're right back to that multiplication and division. If you noticed, we had to do this adding and subtracting a couple of times, and the reason why we had to is because we have variables on both sides of the equation. So you really are just collecting the terms, collecting the variable onto one side, okay? Then it just turns into an equation you've already seen. You've done multiple steps, you've done things with distribution, you've done all those other things. So really the only difference here is that you're bringing it over to one side. Now, would it have mattered if I brought this over here? No, it would not have mattered. I just would have had a -6, and then I would have had to do this over here. See, because if I took that over there, then my only choice would be get this over here because I'm trying to get the x all by itself. So that would have made both of these negative, which would in turn, when I went ahead and divided by 6 on both sides, my answer would be 3. Okay, so that was a lot of words, but this is what your major thing is that you're doing. Okay, so why don't we try an example? Okay, so I'm going to write out, let's do this one. We've got 7k plus 8 equals 2k minus 37. Okay, I wrote that 37 pretty big. Right, so this is what I want to see right here, is that I can tell that this is two sides of an equation, all right? So we can look at it like our balance again. I have a K over here and a K over here, so I need to somehow get those two together. And then I have a constant over here and a constant over here, a negative 37. I have to get those to the other side. This is where you can make a choice. You could choose to bring this over here, or you could choose to bring that over here. I'm going to choose to take the smaller number to the bigger number, because then I'm not going to have to deal with a negative variable. But it doesn't matter. I could show you both ways. It would come out to the same thing. I'm going to go ahead and take away 2k from this side, so I'm going to have to do it from here, just like that balance, right? Think of the balance when you're doing that. It leaves me with a negative 37 equals, I've got an 8, and then I've got a 5k. Now it's just back to a two-step problem again. So you see it's really just this one step at this point. Now, since I made the decision to do that, then I have to get my constants to the right-hand side, because I made my decision to make my variables over to the left-hand side. So my inverse operation of adding is to subtract. So I'm going to do that to both sides. I'm left with a 5k. Now I have a negative 37 and then minus 8. So they are the same signs. So they're pretty much just added and kept the sign, and that equals negative 45. And now I'm going to divide both sides by 5. And I've got k equals, and it's a negative divided by a positive, so it's a negative, and 45 divided by 5 is 9. Okay. So you'll say, hey, Miss McConnell, what if I just wanted to take that 7 over? Because typically students will see this and they want to get things over. And another mistake that students make when they start doing this is they start moving everything over to the other side, and you'll see why that doesn't work. You never want to end up with a 0 over here at this time. So let me just show you what happens if you decided to go the opposite way. Okay. I decided to take 7k from this side. Okay, that cancels out, leaves me with 8. I have a negative 5k and 37. I would have just added 37 to this side, and look what happens. It's still this 5. Now I just have a negative 5 that I'm dividing by instead of a 5. Notice that this one was a negative 45, this one's a negative 5. It doesn't really matter, you end up getting the same answer. So what you have to do is get all the variables on one side. This is the most important thing that you are focused on. Because once you do that, you kind of intuitively know that you need to get the other things on the other side. Then you get all constants, which those are numbers that don't have variables attached to them. Get all constants to the other. Okay, so those are your steps on this one. Right, now there are a couple different kinds. So you're going to be getting a worksheet right now, and you're going to be getting a little form. So let's go over this real quick. So you're going to be getting this worksheet, all right? But before we go over that, I want to show you this little slip that you're getting right here, okay? So this shows that there are a couple other things, and these are the steps that you would go to. So if there was some distribution, you would distribute on each side. If there were any combining like terms, you would take care of that on each side first, and then you start moving things. Okay, so let me show you some examples, and you can use this for your homework too. Okay, so as you can tell right here, this is the first one that we did on our balance, okay? And this is the one that we just did together on this piece of paper right here. Okay, so as you can tell, this and this. So if you need to go back to the video, okay, to go ahead and show me that how to solve it, go for it. Okay, and you're going to try these. I just want you to realize that these are like this, right? Okay. So this is what you're going to work on. And I'm going to give you the answers right now, all right, to 3, 4, 5, 6, 7, and 8, okay? And you're going to work towards those. So the answer to number 3 is m equals 2. Then you've got y equals -6. Then you've got a equals -10. 6 is w equals 12. P equals 4. And C equals -8. Now, if you were to get your answer that says -8 equals C, that's fine too. That means the same thing. I'm just putting the variable first. You don't have to have the variable first. Let me repeat that. You do not have to have the variable first. If you solved it and you got -6 equals Y, that's still the exact same thing. Okay? Now, I want to give you another example. So let me grab that out.